Hello students, I'm back with another video on number system arithmetic, and we have covered number system arithmetic addition and number system subtraction. Addition we have covered for all the number systems that you can see in the previous videos, and subtraction we have covered till now for binary number system and decimal number system. And in this lecture we will cover subtraction of octal number system and hexadecimal number system. Okay, so uh, the the rule that you need to remember is that the side giving the borrow is decremented by 1 and the side which takes the borrow is incremented by the base. This is the rule that we will use in octal number system also. So I will write this rule first. The side or digit which asks for borrow gets incremented by base, and the digit which gives borrow gets decremented by 1. Okay, so this is the golden rule that you need to remember while doing any kind of subtraction for any number system. Okay, so I will start for octal number system with the help of an example. Let us take this example, right? 476 in octal is subtracted. This is minuend, this is minuend, and the subtrahend is suppose I take 3, 4, 7, right? So if I subtract these from each other, so 6 minus 7 is not possible in octal, so it will ask borrow from its left side, right? And it has sufficient amount of it has sufficient amount available. So what it will do, it will itself get reduced by 1, so it will become 6. Okay, and it will give borrow in the form of the base, so it gives it 8. Okay, it is 6 and 8 more comes, so it becomes 14, right? And it becomes 14. 8 plus 6 is 14. 14 in decimal. And how you write 14 in octal? You write 1 6. Okay, so this 1 is added before this 6. Okay, now if you observe closely, what earlier we do, the if this 0 asks the borrow, so what happens, this 0, a 1 is added to the left hand side every time it receives a borrow. uh, a 1 is added on the left side. This is what happens here also. This 1 is added, this 1 is added on the left side of the same digit. Okay, but this number is not 16 of decimal, right? It is 1/6 of octal. It means it is 14 of decimal, right? So if from 14 of decimal you subtract 7, so the result is 7. Okay, don't try this. 16 minus 7 is 9. No, there cannot be 9 because it is a octal number. And anyhow, this logic is wrong to do 16 minus 7. This is not to be done. Okay, you have to do 8 and 6, 14. 14, this is changed to 14. Okay, because 8 received as borrow and 6 was already there, so it becomes 14. 14 minus 7 is 7. Okay, now 6 minus 4 is 2 and 4 minus 3 is 1. So 127 in octal. Okay, and if you want to check the answer, you first convert this into decimal, which is I think it is 300 and it is 318. It is 318 in decimal, and this is 231 in decimal, and if I subtract them it gives me 87 in decimal. Okay, and if you convert it into octal, so octal, if you convert it into octal, you receive 127 in octal. 64 plus 16 plus 7, this gives us 87. So this is, by this way we can reverse check that our answer is right. Okay, I will do one more example. Okay, so I will do one more example for octal subtraction. If I take 6, uh, 6, 0, 0, okay, and I subtract 4, 2, and 7, suppose. I subtract this 600 in octal and 427 in octal. Okay, don't take it like 600 minus 47, 427. This is not like that. Okay, it is 600 in octal is subtracted from 427 in octal. Okay, now 0 minus 7, this is not feasible, right? So it will ask borrow from here, but it is again 0, so it will not be able to give borrow, so it will ask from here. So this quantity gives borrow, so it is reduced by 1, so it becomes 5, and this quantity receives borrow, so it gets incremented by the base. It is 0 and it gets incremented by 8, so it becomes 8. And if we see how we write 8 in octal, is this 108. Okay, now 8, but this does not needs to keep the carry. Okay, so the carry the borrow needs to be shifted on the right side. So it is 8, 8 is again reduced by 1, so it becomes 7. Okay, now 7, and if the borrow is transferred here, so it becomes 8. Okay, it was 0, 8, 8 is received, so 0 plus 8 is 8, and in octal we write 10 as 8. Okay, so this is not 10, right? This is 10 in octal, and which is, it denotes 8. Okay, now 8 minus 7, it gives us 1. Okay, it gives us 1, and it is 7 minus 2, it gives us 5, and 5 minus 4, 10 minus 7, sorry, 8 minus 7, it gives us 1, 7 minus 2, it gives us 5, and 5 minus 4, it gives us 1. So 151 in octal. This is the way how to do octal, octal subtraction. Okay, you can check the result also. We can convert them into decimal. If if I convert this into decimal, this will give me 384 in decimal, and this will give me 427. This will give me 279 in decimal, right? And if I subtract them, this gives me 105 in decimal. And if I convert this 105 in octal, it gives me 151 in octal. Okay, 151 in octal. Okay, so this is how we can verify or recheck our whether our result of subtraction is correct or not. Okay, so the rule that you need to remember is again the same. The side which asks the side which asks the carry gets incremented by the base, so the becomes one. One is added on the same digit. Okay, like 0, 1 is added to the same digit 0. Okay, now we will see one more example for the particular subtraction. Let us do this. Hmm, Suppose we have 6 to 6 and 1 for octal, and it will be subtracted from, suppose I say it is subtracted from 5, 4, 7, and I will say 5. Okay, let us do this. Fine. So uh, 1 minus 5 is not feasible, so it will ask carry from its left side. It has sufficient amount, so it will give carry and reduce itself by 1, so it will become 5. and the carry is the borrow is transferred to right side. So this one takes a borrow, this one takes the borrow, and this one takes the borrow, so it becomes 8. It this So this 6 reduces by 1 and it becomes 5, and this 1 is incremented by 8, so it becomes 8 and 1 9, right? So 9 in decimal, so in 9 in decimal we write 1 1 in octal. Okay, so 1 1 in octal. So what you can see, this one digit gets added a 1 in its MSB. Okay, so it becomes 1 1 in octal. 1 1 in octal is 9. 9 minus 5 is 4. Okay, 5 minus 7 is not feasible, so it will ask borrow from here, so it will get reduced by 1 and it will add 8 to it. This is 5 and 8 is added to it, it becomes 8 plus 5 is 13, and 13 we write 1 5 in octal, and 13 minus 7 is 6, right? Okay, now this one is 4. Okay, don't do this like 15 minus 7. Okay, 15 minus 7 is not right. Okay, you have to do it as 8 plus 5 is 13. 13 minus 7 is 6. Okay, now this one alone cannot help, so it will ask borrow from here, so it will get reduced by 1, so it will become 5. Okay, and it will transfer a borrow to here, and 8 is added. 8 plus 1 becomes 9, and 9 is written as 1 1 in octal, so 9 minus 4 is 5, right? So 5 6 4 in octal. This is the result of this binary subtraction. Okay, so only the rule that you need to remember is this. Okay, I'm going to write some practice questions for you. The first practice question is, okay, and this is a first octal number, and you need to subtract, okay, so this is the second octal number. Okay, so this is minuend and this is subtrahend, and you have to do subtraction of both of them. Okay, the second practice question is this. Mm, Second practice question is 4. Okay, and this is our first octal number, and I will do subtraction from here, so it will be 2. Okay, okay, do this subtraction. Okay, these are two practice questions to do you, and what you can do, you can use an online converter, or just reverse check also, fine, reverse check also for your result of conversion. Okay, now I will do subtraction of hexadecimal numbers. Okay, hexadecimal number and octal number subtraction does not differs much. The only difference is that here that every time a borrow is asked, so 16 is transferred, right? Because the base is 16, and the digit which gives the borrow is decremented by 1 only. Okay, so that rule is same, decrement by 1, but the borrow comes as 16 as a unit. Okay, so I will directly start with one example. So if I take this example, a 9 2b Okay, and I subtract it from 9a c c. Okay, I have taken a difficult example, but it should not be a problem because we have done already practice for different number systems, and this is not a much differ. Now see this. This is hexadecimal number system. So B minus C. Okay, B is for 11. Okay, B is for 11, and C is for 12. So 11 minus 12 is not feasible, right? So it will ask borrow from here. So it will get reduced by 1, and 16 will come here. Okay, 16 will come here. So it will become 11 plus 16, that is 27. And if you check how we write 27 is 1, and how we write 27 is 1b. Okay. So 1b, 27 we write as 1b. So this b, before b, a 1 is added, so it becomes 1b. But in the decimal, you can remember this is 27. So 27 minus 12 gives you 27 minus 12 gives you uh, 15. Okay, and 15 in hexadecimal is f. So this result will be f. Okay. Now see this when I'm doing this. Okay. Now this 1 minus c. Okay, 1 minus c is not feasible. 1 and c. Okay, 1 minus c is not feasible. So this 1 will ask borrow from its left side. So it will get reduced by 1. So it will become 8. And this quantity will become 1, 1. How it will be 1, 1? 1 plus 16, it will become 17, and in 17 you write as 1, 1 in hexadecimal, right? Okay, now 17 and C you write as 12. 17 minus 12 is 5. Okay, 5 in decimal, or you can directly write here 5, right? 5 in decimal and 5 in hexadecimal. Same. Okay, now 8 minus A. I am doing this. 8 minus A. Okay, so 8 minus A. This we are doing. A is 10. Okay, and 8 is simply 8. So it needs borrow from its left side. So this is A. Okay, A gets reduced to 9, right? A is 10 and it gets reduced to 1. That becomes 9. So and here 16 is added. Okay, so it becomes 1, 8. I will add 16 here. 16 and 8 is 24 in decimal. And how you write 24 in decimal is 1, 8 in hexadecimal, right? So 24 minus 10 is 14 in decimal, and 14 in decimal is written as B in hexadecimal, right? So the result will be D. Okay, so 18 minus A is D, right? Okay, now see this 9 minus 9 is 0. So this is D54 hexadecimal. D5F is hexadecimal result. Okay, so I will do one more example for you. Suppose I do this subtraction. This is A, A, and I will do subtraction as 9, uh, or I will do subtraction as 7, B, C, D. Okay, now suppose I do this, right? Okay, now you can now you can do it with the help of the same. You solve it digit by digit because it might get a bit complex for you. So you can solve it digit by digit. You write A, and the other one is, okay, the other one is D. Okay, A means 10, D means 10, 11, 12, 13. Okay, 10 and 13. 10 minus 13 is not possible. Okay, so it will ask borrow from its left side. So this A will get reduced to 9, and this will become 1a. Okay, this will become 1a. How it will become 1a? Because it will get 16 as an borrow, so it will become 26, and 26 in hexadecimal it is written as 1a, right? 1a in hexadecimal and 26 in decimal. Okay, so 26 minus 13 is 13 in decimal, and how you write 13 in decimal is a b c d. Okay, d you write as, sorry, this will not be, I have written it wrongly, it is e, right? 14 is e, so instead of d the result will be e. Okay, now 13 is d. Okay, so d in hexadecimal, so 1a minus d is d, right? Okay, now 9 minus C. I am solving this particular digit. So it is 9 and C. C is 12. Okay, C is 12 and 9 is this. So C is 12. So if I do this, so I have to ask carry from here. So it will get reduced to 9 and this will get incremented by 16 and it will become 19. How it will get? Okay, 9 plus 16 is 25 in decimal, and how you write 25 is 1 and 9 in hexadecimal. Okay, and 25 minus 12, it will give me 13 in decimal, and how you write 13 in decimal? As d. Okay, 13 in decimal is d, right? So 13 is decimal is d, so you will write d here. Fine. Now again 9 minus b, uh, this bit you have to resolve as 9 and b. So 9 minus b is not possible, right? So 9 will ask carry from here. So this will get reduced to 9 because this is 10, and 10 will get reduced by 1. It will get reduced to 9 and it will become 19. Okay, 19, not 19, it is 1 9 in hexadecimal. So plus 16, 16 plus 9 is 25 in decimal. Okay, 25 in decimal, and I can write it as 1 9 in hexadecimal, and if I take it, b means it is 11, so I will subtract it from 11, 11 in decimal, and if I subtract it from this, it gives me 14 in decimal, and 14 in decimal is written as e in hexadecimal, right? So the result would be e. Fine. Next is 9 minus 7, it is 2. It is quite simple, and this is the result of subtraction. Okay, so I hope you remember the rules of hexadecimal. Also do the practice. Now I am giving you some practice questions. First practice question, you can take like, this is your first practice question, and second practice question that I will give you is this. These are your two practice questions, and you have to do reverse checking also for the same. So this completes our hexadecimal subtraction. Next we will do the subtraction with another method of complements. Till then, stay safe and do the practice. Thank you.